topic of this presentation is solving and graphing an inequality in one variable, where there's just an x or a y or a different variable, but not two variables. It is very similar to graphing an equation. You have to separate the sides and isolate the variable. So in this case, we would subtract 5 to get 6. So 2x equals 6, divide by 2, so x equals 3, and graphing it on a number line, we would just put a closed circle at 3. If you can do this, you can solve an inequality. You know that an equation contains an equal sign. That's what makes it an equation. An inequality has a less than, a greater than, a less than or equal to, or a greater than or equal to. It includes an inequality symbol, and that's what makes it an inequality. As I said, solving inequalities is very similar to solving equations. The goal is to get the variable on a side by itself using inverse operations. The solving part is exactly like with equations, where we draw a line separating the sides. We use inverse operations to solve for the variable, making sure that we're using the inequality symbol, not an equal sign. So now we have x is less than 3. So x can be any number that is less than 3, like 2 or 1 or negative 100 or 2.5, but it does not include 3 because it's not a less than or equal to. So we show that on a graph by using an open circle. If it did include the point, it would be a closed circle. But since it doesn't, it's an open circle, like this. You find the place on the number line, put an open circle where we want to begin, and we use our arrow to show that it's any number less than that. Now we have solved and shown the solutions on the number line. Inequalities are different than equations in one special way. So let's watch. If you have the inequality 2 is less than 4, that makes a true statement, yes. So if we multiply both sides by 2, that gives us 4 is less than 8. That still makes a true statement. But what if we multiply both by negative 2? That would give us a negative 4 is less than negative 8. It is no longer true. It makes an untrue statement, or a not true, false statement. So what we could do to make it a true statement, we would have to flip the sign. So negative 4 is greater than negative 8. Let's try this with division. 2 is less than 4 makes a true statement. But if we divide both by 2, 1 is less than 2, that still makes a true statement. So if we divide both by negative 2, though, that would give us a negative 1 is less than negative 2. It no longer makes a true statement. We would have to flip our sign to have negative 1 is greater than negative 2. So the special rule when you're solving an inequality is when you are multiplying or dividing an inequality by a negative number, you have to reverse the inequality symbol. Reverse the inequality symbol. It only is when you're multiplying and dividing by a negative number, not multiplying and dividing by a positive number, and not adding or subtracting a negative number, only multiplying and dividing by a negative number. So let's try a few examples. I'm going to separate my sides. It is multiplied by a negative 2, so I have to divide by a negative 2. So x is on one side, negative 3 is on the other, and because I divided by a negative number, I have to reverse my symbol. So x is any number that is less than negative 3. This example, the second example, is a little bit more complicated. I'm going to show you one way to solve this. There's a parentheses, which makes me think of the distributive property, so I'm going to distribute over the parentheses. So 2x minus 8. I'm going to put my less than or equal to symbol here, and x plus 3 over here. Now, you could take this x over or this 2x over. For the sake of showing you the special rule again, I'm going to move my 2x by subtracting 2x on both sides. So now I have a negative x plus 3 equals negative 8. I'm going to subtract 3 on both sides, so now I have negative x is less than or equal to negative 11. And because it is a negative x, the opposite of x is less than or equal to negative 11. I have to switch both signs and flip my inequality symbol. So now x is greater than or equal to any number more than 11. So x is any number greater than or equal to 11. If I were to graph this, I would make my number line. We always want to have some numbers before and some numbers after. I'm making a very small one. It's an equal to, so I'm going to have a filled in circle, and it's any number that is greater than 11. And that's the basics of solving inequalities.